Good afternoon, everyone. I just want to quickly demonstrate how we solve the homogeneous equations. So first of all, you must know what a homogeneous equation is. So this is the criteria to check whether a function is homogeneous. Homogeneous equation. How do we know whether a function is homogeneous? A function is homogeneous of, just adjust my camera, degree a function is homogeneous of degree n if m of tx ty equals to tn mxy for all t. This usually applies to polynomials, because let's take for example f at xy. We're talking about function of two variables here, x squared plus y squared, and then let's just say f at xy equals to exy. We want to verify whether these two functions are homogeneous. Let's start with the first function. Let me call this one g of xy, just so that we can differentiate. So to check whether this one is homogeneous, we're going to replace wherever there is x and x squared with tx. M of tx, m of ty equals to tx all squared plus ty all squared. This is t squared plus tx squared plus tx squared y squared. We can take out the common factor of 2. So this is going to be t squared into x squared y squared. M of tx comma ty. So if we take out, you can see that this is the same as m of xy, tx squared m tx ty. Let's call this function m of t xy before we do anything. So you can see that this is homogeneous. It means that criteria. Let's test whether g is exact. We want to see whether we can use this method or not. So m of t xy equals to exy. So if we want to find m of t x ty, we're going to replace x with tx ty e to the power tx ty. So this is going to be e to the power t squared xy, m of tx ty. So there's no way that we can take out the tx squared outside this exponent, so we cannot use the homogeneous equation here. So it usually applies to polynomials. It doesn't apply to trigonometric functions and exponential functions or function of those kind. That's why we need to use this particular method. So now let's do an example. Dy over dx equals to y minus x divided by y plus x. So when we solve this problem, we want to solve the ODE. We let y equal to x v. Then we're going to differentiate this function with respect to x, dy over dx. So to differentiate this, we assume that v is also a function of x. So in order to differentiate this, we have to use product rule. So if we keep v constant, derivative of x with respect to x, it's 1. Then the derivative of v with respect to x is dv over dx. So at the end of the day, we're going to have something of this nature: v plus dv over dx. So from there, we can go and replace. I usually prefer to use highlighters. We can replace this dy over dx with that dy over dx there. And we can also replace wherever there is y, that y and that y, with that. So let's go and replace. Let's open a new page. Let's do the replacement. So we replace dy over dx equals to y minus x over y plus x. So we can, in place of dy over dx, we can put v plus dv over dx, and then in place of y you can simply put xv minus x. In place of y again, put xv plus x, v plus dv over dx. Take out the common factor of x, x into v minus 1, x into v plus 1. So v plus dv over dx equals to x, and x will cancel each other. So that is the reason why we must make sure that these two functions are homogeneous of the same degree, because if they're of different degrees, you're not going to end up finding yourself in a situation when these two cancel each other. V plus 1. So after that, you can take v to the right hand side, dv over dx, v minus 1, v plus 1 minus v, dv over dx, v plus 1. So you take the LCD, v minus 1 minus v into v plus 1, dv over dx, v minus 1 minus v squared minus v over v plus 1. So v and v will cancel each other. So after that, let me write on the left hand side of the book. It's going to be dv over dx to negative into 1 plus v squared over v plus 1. So then you can cross multiply. It's going to be v plus 1 over 1 plus v squared negative dx. I've got dv there. I'm going to write on the new page. After that, you split this two. V plus 1 over 1 plus v squared dv negative dx. So this is going to be v over 1 plus v squared, 1 plus v squared dv negative dx. Let's introduce the integral sign. V over 1 plus v squared plus 1 over 1 plus v squared dv negative dx. So let's integrate this. Negative x plus c. This is half ln of 1 plus v squared plus tan arc of v. So from there, this is going to be half ln of 1 plus. So remember, initially we said let y xv. So if we make v the subject of the formula, v is equal to y over x. So wherever there is v, put y over x. I cannot have double equal sign now, so this is wrong. This is wrong. Squared plus tan arc of y over x equals to negative x plus c. Thank you for watching my video. Don't forget to subscribe, like, and share. See you again next time. Bye bye.